Solutions for quiz, what is this, quiz 6 for Math 251. In the first one, we're asked to use implicit differentiation to find dy over dx for the equations, two of them, jeez. Equations below. Basic idea when you have an equation and you use implicit differentiation, you're just taking the derivative of both sides of the equation. You just treat the y's a little bit differently than the x's. So if I take the derivative of the left-hand side, the derivative of x cubed is easy. It's just 3x squared using the power rule. But the derivative of y cubed is a little bit different. It's actually 3y squared times y prime. But actually, it's the chain rule is what's going on here. Think about it as it's something cubed. So to take the derivative of the cubed part of that, use the power rule. That made this a 3 and this a 2. And then that something in between, you leave it alone. Just write a y right here. Then you're not done. You have to multiply that by the derivative of the inside function, the derivative of y. And the derivative of y, we're using the symbol y prime for. Anyways, the derivative of y cubed is this thing. On the left-hand side, we have to use the product rule. One way you could think about it is the f in the product rule is 3x, and the g is y. So the product rule tells me that the derivative of f times g is f prime, 3 in this case, times g, y, plus g prime, which is y prime, times f, which is 3x. So what we have here is an equation that has y primes in it. I want to figure out what y prime is, so I just solve this equation for y prime. I take all the terms that have a y prime in them and get those over on the left-hand side of the equation. So 3y squared y prime has a y prime in them. If I subtract this term over, I'd have minus maybe 3xy prime, just rewriting this term. And that's equal to 3y, this term right here, minus 3x squared. If I subtract this term from both sides of the equation. And so now I can factor out a y prime since every term on the left-hand side has a y prime in it, and get 3y squared minus 3x is equal to 3y minus 3x squared. So y prime is equal to, if I divide both sides by 3y squared minus 3x, 3y minus 3x squared divided by 3y squared minus 3x. If simplification is your thing, you can factor out a 3 from the numerator and from the denominator and get y minus x squared divided by y squared minus x. I don't really care if you do that or not. You can leave it like this or you can leave it like this, whatever makes you happy. So maybe I'll put a box around both of these because either one would be fine for an answer. Move on to the next one. Another equation. A little bit more complicated of an equation, but fine. Directions are the same. So basically do the same thing. Take the derivative of both sides of the equation. Left-hand side of the equation, what I'm hoping you see is the chain rule. Take the derivative of the outside function to get 3xy squared. But then you're not done. You have to multiply that by the derivative of the inside function, the derivative of x times y. And to figure out the derivative of x times y, you got to use the product rule. F prime is 1 times g, which is y, plus g prime, which is y prime, times x. So the derivative of the left-hand side is all this stuff. Make sure you put these parentheses in here because we wrote a plus. We got to make sure this term hits both of these terms. What about the right-hand side? Well, the derivative of 2 to the y, if it were just 2 to the x, the derivative would be 2 to the x times the natural log of 2. But it's not, it's 2 to the y. So I'm going to write 2 to the y natural log of 2 and then recognize that I'm not done. I still have to multiply by the derivative of the inside function. This is chain rule here. Y being the inside function, derivative of y is y prime. 2 times y. 2 is just a constant, so leave it alone. And then multiply it by the derivative of y. The derivative of y, which is y prime. Y squared. Taking care of the squared part, this is going to involve the chain rule. This did not involve the chain rule. This will involve the chain rule. You bring the 2 down in front, leave the y alone, raise it to the 1 power, but then you're not done. You have to multiply that by the derivative of y to get y prime. Get this huge mess right here. I got to solve this mess for y prime. I can do that. It's a little bit hard because of the parentheses. I mean, the strategy that I'll use, same strategy I used up here, where you get all the y primes on one side of the equation. It's hard to move them around down here, though. It's hard to get this y prime, this term on one side of the equation, and this one on the other, because of these parentheses. So get rid of the parentheses. Take this thing and distribute it into these parentheses. you get 3y xy squared, that's this times this, plus 3, I don't know, xy prime xy squared, this thing times this thing, and that's equal to 2 to the y, natural log of 2 times y prime, plus 2 y prime, plus 2y y prime. Got a y prime in this term, 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 but not in this term. So I'm going to take this one and subtract it over to this side to get 3y xy squared is equal to 2 to the y natural log of 2 times y prime plus 2y prime plus 2y y prime minus this term, 3xy prime xy squared. Now what I have are a bunch of terms on the right-hand side of the equation that all have a y prime in them. So I'll factor out that y prime, and what I'm left with is 2 to the y natural log of 2 plus 2 plus 2 to the y, or 2 times y, minus 3x x y, write that a little bit neater, 3x times xy squared. Sure, you can make this x squared y squared and then call this x cubed times y squared, but you don't have to. Either way is fine by me. Now I just have one y prime as opposed to having four of them floating around like I did on the previous line. So I divide both sides of the equation by all this stuff and end up with y prime is equal to 3y times xy squared divided by 2 to the y natural log of 2 plus 2 plus 2y minus 3x xy squared. Lots of different ways you could write this. Doesn't look like anything will factor out from all of the terms in the bottom. If you took this, xy squared means xy times xy. In other words, x squared times y squared. I could write the top as 3x squared y cubed. And then down on the bottom, leave most of this stuff alone. Except for this last term, kind of the same idea, 3x cubed y squared. Either of these are fine. I don't care which one you give me. To prove that to you, I'll put a box around both of them. There you go. There's some answers. All right, next problem. Find the derivative of each of the following. Oh, at least it tells us some stuff. It says, by the way, the derivative of arc sine of x is this thing. So what I want you to do is figure out the derivative of arc sine of this thing all squared. What I'm saying is I would rewrite this function as it's the arc sine of something. In this case, the arc sine of 1 over the square root of 1 minus x squared squared. So to find that derivative, I'll have to use a bunch of chain rules. The outermost will be, it's a bunch of stuff squared. So the derivative of stuff squared is just 2 times stuff. In this case, the stuff is arc sine of, I'm going to well, no, I won't. 1 divided by the square root of 1 minus x squared. But then I'm not done. I've just taken the derivative of the outermost function, the stuff being squared. So what I then have to do is take the derivative of the next layer. The next layer is its arc sine of something. If it were just arc sine of x, my derivative would be 1 divided by the square root of 1 minus x squared. But it's not arc sine of x, it's arc sine of all this stuff. So instead of writing an x right here, I'm going to write all this stuff. 1 divided by the square root of 1 minus x squared squared. You could simplify this. The square root and the squared cancel out. A lot of stuff cancels out here. You don't have to, though. You can leave it just like this if you want. Then you're almost done. What you have to do then is multiply by the derivative of the final layer, 1 divided by the square root of 1 minus x squared. I think it might help to look at this somewhere else. Let's say note, this 1 over the square root of 1 minus x squared, the thing that I still have to take the derivative of, is just equal to 1 minus x squared to the negative 1/2 power. So when I come up here to take the derivative, I'm going to think about it, oh, it's power rule. The outside function, it's stuff raised up to the negative 1/2 power. So the derivative would be negative 1/2 times the stuff, 1 minus x squared, raised up to, I have to subtract 1 from that exponent to get negative 3/2. Now I'm still not quite done. I have to multiply that by the derivative of the inside function being 1 minus x squared. The derivative of 1 minus x squared is negative 2x. What I get for my final answer is this thing, which you can absolutely simplify if that'll make you happy, or you can leave it just like this if you don't feel like simplifying. I don't feel like simplifying, I'm going to leave it just like this. All right, down here, I actually have product rule going on. The f in my product rule is just an x, and the g is arc secant of, what's the easiest way to write this? I'm going to say it's arc secant of x to the negative 1 power times x squared minus 1 to the negative 1/2 power. This thing inside the parentheses here can be rewritten like this. I think this will make it a little bit easier. You can do it different ways. F prime, that's easy. It's just 1. G prime, not so easy. Okay, well, if it were just the arc secant of x, I could come up here and say the derivative of arc secant is just 1 over x times the square root of x squared minus 1. So I'd write 1 divided by x times the square root of x squared minus 1. But it's not the, I'm not trying to find the derivative of arc secant of x, I'm trying to find the derivative of arc secant of all this stuff. So in each of these parentheses, I'm going to copy all that stuff, x to the negative 1 power, x squared minus 1 to the negative 1/2. Over here, x to the negative 1 power times x squared minus 1 to the negative 1/2. This is not g prime. This is the first layer of the chain rule to figure out g prime. I've taken care of the arc secant of x, or the arc secant part here. I have to multiply that by the derivative of what's in the parentheses here. To figure out the derivative of what's in the parentheses here, I'm going to have to use another product rule. I'm going to make my f be equal to x to the negative 1 power, and my g be equal to x squared minus 1 to the negative 1/2. If f is x to the negative 1, f prime is negative 1x to the negative 2, using the power rule. G prime would be negative 1/2 stuff, x squared minus 1 in this case, to the negative 3/2 times the derivative of that stuff, 2x in this case. So using all this information here, I can say the derivative of what's inside the parentheses here is f prime negative x to the negative 2 times g negative 1/2 x squared minus 1 to the negative 3/2 times 2x. Can that simplify? Yep, but you don't have to. That plus g prime, wait a minute, f prime times g, damn, I wrote the wrong thing. Let's try that again. F prime is this, times g is just this guy, x squared minus 1 to the negative 1/2. And to that I want to add g prime, which is all, I want to add a negative number, maybe I'll just say minus 1/2 times x squared minus 1 to the negative 3/2 times 2x, f prime g plus g prime, it's hard to see that, don't know why that won't stay, but whatever, plus a negative, so I'll write minus g prime and then f, which is x to the negative 1 power. Something like this is your answer for g prime. So for our final answer, I say it's f prime times g. How about the derivative of the function in question is this times this. It's the arc secant of this thing. It doesn't matter how you write it. I'm going to write it the way it was written in the original problem. F prime times g plus g prime, all this stuff, you know, to try to save room, this times this, I can take all this stuff and put it up on top. It'll look weird to have negative exponents on the top of the fraction. That's okay. Not too concerned with stuff looking weird as long as you got something that's equivalent to the right answer. Divided by this stuff here. Keeping track of all the pieces is part of the challenge. Almost done. Be easy to, well, I don't know if it'd be easy. Be possible to get here for your answer, but remember we were doing the product rule, so it's f prime times g plus g prime times f. I need to take this huge mess I wrote and multiply it times an x. You could simplify this. You could spend an hour simplifying this if you really wanted to. I really don't want to. So I'm going to call that my answer. That or equivalent is my answer. That's the end of this pretty challenging quiz.